Okay. So in series, this is how you connect in series. That means you go inside the other side of that equipment go out. Inside the other side of the equipment go out. Okay. The positive you go in, the negative you come out. Positive go in, negative come out. This means a series. Okay. In series, the current is same. Say it's 2 amp. Here also 2 amp. Here 2 amp. 2 amp. The current is in ampere. Okay. The unit of current is ampere. Okay. Uh, okay. So the unit of voltage is volt. Okay. Unit of current is ampere, and then unit of resistance is ohm. Okay. So ohm, ampere, and volt are different scientists. Okay. Volt came from a scientist named Volta, an Italian scientist, Volta. Ampere is from a French scientist named Ampere. And ohm is from a German scientist named Ohm. Okay. So these are the units. Okay. The unit of the I mean the factors of electrical. Okay. So voltage is the same in parallel. That means here is 12 volts, here is 12 volts, 12 volts, 12 volts. And then current is the same in series. It is 2 amp here, there'll be 2 amp here, 2 amp here, 2 amp here, 2 amp. So this is meaning of parallel and series. Okay. So here you see that the positive and negative, say your handphone, got a positive, negative, you just join like that. This positive for this positive, this positive. Here the negative, negative, negative. Here positive, come out, the negative join here. Here positive, go out negative, join here. So that's a series. Okay. So basically this page is the most fundamental of the whole electrical. I'll send this to you, okay? I wrote a book. I don't have my book here, but and my book is in the library, the UCGS library. I'll show you my book. Okay. Okay, let me see. Come on. Okay. Okay, this is my book. You just put electrical power, even slightly wrong spelling, also they can. Okay. So you can see my book. Okay. Wow, 5-star rating. I also did not. Like a 5-star rating on my book. Yeah, 1, 2, 3, 4, 5. Yeah, 5-star rating. So this is how it looks like. So the first page of my book is actually I got reviews. Let me check this one. Kindle edition. Never mind. One rating. I don't know. I don't read all this. Never mind. Okay, so so that's my book, and the book's first page, first few pages, okay, it's just describing this. Okay, so first few pages is just describing. So it's because it's most fundamental. If you do electrical, you don't know this basic thing. Sometimes you get things wrong. Okay, so I explain it in detail in the first few pages. Okay, when you on a switch, immediately current goes to the end. Okay, how does it work? You imagine you got a pipe. There you got a pipe like this, okay? And you got small, tiny ball bearings inside there, okay? And then you push one ball bearing here, immediately the last ball bearing will move, right? So that's how it works. That's why it looks like immediate, okay? So if you on a switch in Bakun and it goes to Cebu, immediately Cebu will be on. Because like this, see, the electrons are like ball bearings inside here. You push this one, the last one straight away move. Okay. And then the resistance, there are three kind of resistance. Okay. 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 Okay, so there are three kind of resistance. That means there are three things that can slow down the electrons. Okay. So the first thing is just going through some materials that are not easy for the electron to flow. Okay. If you have a copper, it can flow very nicely. Okay. But if you have okay, don't say plastic, it cannot flow, right? If you have iron, it cannot flow as well. Okay. You have iron, it cannot flow as well. And then let me low down something, lead, plumb, it doesn't flow very well. Okay. And then when you go to plastic, it very hard to flow. Okay, it's almost impossible to flow. But you cannot say cannot flow. You don't say all plastic cannot flow, because if the voltage is high enough, you can still flow. Okay. Anything electric can flow. It's just a matter of how high the voltage is. You know, I went for a bomba course, you know, the fire brigade course. So they say that anything can burn if you got enough heat. You can burn anything. No, even cement. I don't know if you heard about the twin towers. You know, the twin towers that fell down. Okay, there's nothing left. What happened to the building? There's nothing down there. When it fell down, there's nothing left down there, because everything burned. Even the cement, everything burned. The steel, everything burned. Okay, so everything can burn. So similarly, if plastic, you say cannot flow, but you put enough voltage, it still can flow. Okay, so you must be careful. Don't say, "Hey, this is plastic insulator, go touch." You must be careful if the voltage is very high, it can still flow. But around the house and office and factories, the voltage can be only 2 voltages. Okay. Okay. The voltage around the house, buildings, or factories, only 2 different voltage in Malaysia. Okay. 240 volts and 415 volts. Okay. Different country, different. In China, this one is 220. Okay. USA, this one is 120. Japan, about 110, like that. Okay. 110. Yeah, Japan is about 110. Okay. But we follow exactly England. In fact, there are very few countries following exactly England. Okay? Malaysia, Singapore, India is following exactly England. Malaysia, Singapore, India is following exactly England. Even Australia and New Zealand don't follow England. Okay? Uh, in electrical, because you see, in electrical we got the color codes also for all of the wires. We follow exactly England style. Okay. Even Australia's leader is a Queen of England, but they don't follow the electrical of England exactly. Okay. So I'll send you this page. This page definitely the most critical. So definitely come on your exam. Okay. All these things are very important. Remember to vote it. I'm surprised some people, a lot of people don't know this one. You know how I know. Some people submit for review, for research project, and then they could put the voltage to 220. So I know that one they copy from China. Okay. Okay. The voltage in Malaysia is 240. Okay. So what is the meaning of this voltage 240 and 415? Okay. You see, the wires coming out of Bakun is like this: red, yellow, blue, and neutral. Of course, the wires are not colored on the overhead line as red, yellow, blue, neutral. But when they go inside the factory, they normally use the wires red, yellow, blue, neutral. Not normally, in fact, it is a requirement. In the factory, you need to use different color. If red face, you must put red wire. Yellow, blue, and neutral are normally black color. Okay. Okay. So how does this happen? It happened in Bakun. Okay, because our main power is from Bakun, right? So okay, this was all invented by Tesla. Okay, let me show you Tesla. Okay, Tesla. It's not sharing, so you guys cannot see. So let me show you again. So all these are very, very critical. Okay, here, let me go through again. V equal IR is most important formula. Okay, it's called Ohm's law. And then V, the unit is volts. I, the unit is current. R, the unit is ohm. Okay, and then there's two different voltage in the homes, 240 and 415. Okay, it not all homes, but in, can say, rich people's home, factories, and most office, they got 2 voltage. But in most people's home who are sederhana, I mean, not so rich people like me, my house is only 240. Okay, in a bit richer people's house, you can get 2 different voltages, but they normally don't use the other voltage. They only use this one. Okay, but in rich people's house, they can, if they want, use a big equipment that requires this. Okay, and factories, that most factories, they have this voltage. Okay. Okay, and then I told you that there are three different kinds of things that can stop the flow of electron: resistance, capacitive reactance, and inductive reactance. Okay, let me explain later. Okay. Okay. So you see, how did this happen? Okay. You see, this is Bakun. Okay. So in Bakun, you have a coil there and then a coil here. They are joined to each other. It is. Actually, it is one wire. This is going to Sarawak. Okay. Going to Sarawak, they put a coil and then they join here. The same wire will go in a coil here. But the thing is that this one is a clockwise coiling. Okay, this is clockwise, and here they call anti-clockwise. Okay, so how does that happen? Okay, you see, when you get a wire like this, okay, the magnet, you must remember this rule, FBI. I don't know, your teacher might not have taught you so far, but this is the rule of electrical, FBI. Okay, so F is the force, B is the magnetic field. That means north south. I is the current. Okay, FBI. Okay. Normally in school they teach you like that lah. The force, the direction of magnet. The direction of magnet, that means north south. Okay, and then the current will be here. Okay, so you must put like this. Okay, so every electrical course you learn this thing, FBI. So magnets are like this. Okay, the direction of the different forces in magnet is like this. Okay, so you must, how you do it, you put it like a gun first. Okay, you put like a gun and then like that. If you don't put it like a gun, you put like that, then you get it wrong. You say FBI, wrong already. Okay, so you must put like a gun first and then FBI. Okay, so okay, how does it work? You see, you got a wire here, and then this is a magnet. The magnet has a FBI. Okay, get something. Okay. So this is a wire and a magnet. Magnet has FBI. Okay, and this is the direction of the magnet moving. The F is the direction of magnet moving. The magnet is facing down. Okay, so it moves across a wire. The current will come this way. The current comes this way. So it moves around a wire, it comes this way. Okay, so what does a wire see? See, the magnets like this, you've got the field lines around the magnet, the magnetic fields. Okay, I don't know if your teacher showed you, you get a paper, put a magnet at the bottom, and here the dust from iron. When you cut a piece of iron, you got dust, right? They call it iron filings. When you put it there and then you put a magnet down here, okay, you'll see the field lines. Okay, all of you have seen that in school. I think they teach you in lower secondary school, from 1, from 2, from 3. Okay, let me show you anyway. Okay. Okay, this is how it looks like. You see, you put a magnet, you can see the field lines. Okay, you put a magnet below a piece of paper, and the magnet below the piece of paper, and then when you put the iron filing, that means the dust from when you cut a piece of iron. Okay, so you will have this. So these lines are the field lines. Okay. Yeah, I just made a note of it. Okay. Okay, so okay, so you see, like I showed just now, this has magnetic field lines. So what does this one see? This wire, copper wire. This will see one line because it's quite far, right? You see one line, and then you see two, and then you see 3, 4, 5, 6, 7, 8, 9, 10. Okay, because this maximum, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So what does a wire see? A varying magnetic field line. Okay, the number of field line varying. Okay, so what they call it is okay, varying field density. Okay, that's the meaning of what this one is saying. At first you see a lot, and then you see so at first you see little, and you see more and more and more until you see little again. So the number of field line this one sees is changing. Okay, so what I did in my book, okay, I put in my book like this: varying field with capital F density. Okay, capital F. Okay, uh, So that way you can still use this as F, because in school, in all schools in the world, they teach you this one is F. But there's a problem if you say this is F. There are some things you cannot explain. So I say this is wrong. You must call it varying field density, then you can explain everything. Okay, so that's why in my book, instead of calling this force, I call this F varying field density. Okay, varying field, so still F density. Density is, you know, a lot. Okay, like for example, okay, Cebu, I'm living in Jalan Tebu. Density of people here, not so many. You go to center of town, density is a lot. Okay, that's the meaning of density lah. Okay, the English word I just want to explain to you. If you have a function, nowadays COVID no function, right? If you have a band playing in Cebu, density of people is a lot. Okay, you have no function. Say there's a park near the CIMB bank, because that's my bank. Sometimes I go there, there's an open area there. I don't know if someone play a band there or not. Okay, okay, that place, if there's a band playing, density of people is high. If there's no band playing, low density. One or two people walking around here exercise, that is low density. Okay, same thing. Okay, so what is required for generation of electricity is a varying field density. Okay, you see this one is moving like that. This one, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It must see a varying field density. If you put a magnet here on top, there's a lot of density, right? Because 10 field lines there, right? No current. You can put the biggest magnet in the world on top of a wire, but no varying field density. There's no current. You must have a varying field density. Okay? The biggest magnet in the world is in CERN. CERN is a research place in Switzerland. So you can put that magnet, giant magnet of CERN, you put it on top of a wire, okay? There's no electricity generated. It must have a movement for electricity to be generated. Okay? So the movement of the magnet or some other methods to get the density to be varying. Okay? One other place where they use this is a transformer. Okay? Transformer is 2 coils. From this coil, it can go inside here. But transformer is no moving parts. There's no movement. But still got, from here can jump to here. How? Because this one is varying. Okay? I think you heard that the AC wave is like this, right? So, like that, very low density, high density, low, high, low, high. This one gives varying field density. That's why even though inside the transformer there's no moving parts, from here can jump to here, because it has varying field density. Okay? So just like this, got varying, this one will see varying field density. This also see varying field density even though not moving. Not moving also can see varying, because the current inside here is already going like that. Okay? So it's low density, high density, low density, high, low, high. Okay? So you see a varying field density. Okay? That's why in transformer, you can jump from here to here, even though there's no connection between these 2 wires. You can jump from here to here. Okay? Because you got varying field density. Understand? Huh? So that's why in my book, I use the word varying field density instead of force, which they teach in almost all primary school or secondary school. I think Form 1, Form 2, Form 3, they teach you this one. FBI. Okay? Okay? The reason I want to do that is so I can explain other things like transformer. Because transformer, if you say force, you go to secondary school and then must have movement. This one must move before this one got current. Transformer no movement. How got current inside? How the current can jump from here to here? Okay. Similar, your handphone. You see the latest handphone, Apple. Mine is old one lah. Mine is very old. Asus. I think they don't even sell Asus anymore. But if you're the latest Samsung or iPhone, you can put it on a pad, and then from here can jump here. How? Exactly transformer. No movement. You see, there's no movement. This one not moving. This one also not moving. How come the current from here can go here? Exactly like transformer. Okay. The transformer has no movement, but the current inside is varying field density. That's why you can jump from here to here. So, how they make this thing happen for the handphone? They just increase the wave. You see the wave like that, right? They make it instead of like this, right? They make it. That's the meaning of high frequency. When they make it high frequency, you can jump further away. Okay, low frequency, the two coils in transformer must be very close to each other. Okay, you want it to jump from here to here at different space, like from a handphone to a space like that. Then you must increase the frequency. Increase, you can even put further away. Okay, they already have like electric car. Okay, on the car park in your house, they put a pad like that. The car goes over there, and then from the pad, it can charge the car. Okay, the wheel is the car is over there high, right? You can still charge. Okay, why? Because the wave, instead of like that, you can go. That meaning high frequency. Okay. Okay. So how the wave become like this? Okay. So if you look at this, the center of this is a magnet. Okay. The center of this is a magnet. Magnet have north and south. Okay, that's the nature of magnet. Magnet have north and south. Okay. So in Bakun, they don't use a solid magnet. You know, the magnet that they buy in supermarket. I mean, not supermarket. I mean, you've seen magnets, right? I don't have a magnet here. Oh yeah, I should bring one. Next class I will bring a magnet. I have a lot of magnet in the university. Okay, I got quite a lot for one of my research. Okay. By the way, for your information, Japan is a leader of magnets. Okay. Specifically, a company called Hitachi. They're the leader of magnet worldwide. Okay. So you want a very strong magnet, you go to Hitachi. Okay. They keep increasing the strength of the magnet every year. Okay. So you see, you can use a permanent magnet, or you can use a coil. A coil with current going inside will behave exactly like a magnet. So the coil with current going inside is called a coil with current going inside is called a solenoid. Okay, solenoid. Okay, so a coil with current going inside is exactly like a magnet. Okay, because they're basically inside a magnet, the same thing happens. Okay, so that's why you can replace a magnet with a coil with current going inside. Okay, so in big generators like Bakun, they don't use permanent magnet, they use a coil. There's a reason for this, because magnet is iron. You know, iron besi, yeah. Okay, this is iron. Okay, iron are magnets. Okay, the difference between iron, you see, this one is not magnetic, right? I take another piece of iron, there's no magnet, right? But if I take a magnet and go and swipe on this one, okay. I remember my son was doing this experiment. When he was very small, he liked to do this kind of experiment. I think good next time some of you finding girlfriend, boyfriend, going to get married, so going to have a child. It's good for them to buy some of the experiment books. I can tell you because that son who would like to do the experiment got a scholarship to go to Japan to study. Indian, normally very hard for Indian to get a scholarship. I think there's a person in Sarawak. Okay. So when he was young, he asked me for some books to do experiments. So I buy him some science experiment books. So he opened a book, and he said, "Okay, when you make a vessel, change it into a magnet, you must swipe." And they say swipe 40 times. Okay, I remember he told me 40 times. He was, I think, primary 1 or something. And then that thing became a magnet. I think he didn't use this, like he used a nail. They recommend him to use a nail. Okay, a big nail. I give him a big nail like that, and then he can swipe. Okay, so it's a good idea, lah. You buy science books for your children, and then they'll be pretty smart. He never got a B in his life, only A, all the way until 4-5, and then government gave him a scholarship now. Okay, so now he's in Japan. So anyway, okay, so iron is a magnet. The reason why they don't use a permanent magnet here is because iron, a magnet, when you burn it, it changes back to iron. Okay, let me show you the difference between a solenoid and a magnet. Okay, so you see, this is a magnet, iron, basically iron. Inside iron got different holes. Okay, they got a name for these holes, lah. Okay. Okay. These holes are called domains. Inside the domains, maybe there's 3 electron or 2 or 5 electron, maybe. Yeah, they'll all turn in one direction. This one will turn another direction. This one will turn another direction. Because they turn in different direction, it is not magnetic. So iron is not magnetic because they turn in different direction. Okay. So what you do, like I told you, my son get a nail, and then the book instruct him to swipe 40 times. What happening is this one will all start turning in the same direction. Okay. When they all turn in the same direction, that's when the nail became a magnet. Okay. So to replace this thing, you can replace this whole system with this one, a coil where you send current inside. It's also electron turning in one direction. As long as electron turn in one direction, it becomes magnet. Here also electron turn in one direction. That's why a magnet and solenoid is the same thing. Okay. Okay. This is magnet. Okay. So solenoid, permanent magnet. Okay, solenoid, permanent magnet. Okay. So these are domains. Okay. As long as you swipe the nail many times, this will all be in the same direction, then this iron becomes a magnet. Or you can use a coil and you put current inside there, and that means all electrons moving in the same direction, it becomes a magnet also. Okay? So coil can replace a magnet. So what in vacuum they use is a coil. They don't want to use a permanent magnet like this one because inside the generator of vacuum, which is very huge, it's too hot. Okay? When it's too hot, this one, if you use a permanent magnet, it turns back to iron. Okay, so that's why they use a coil. Okay, so of course, whenever you want to give current to something that's turning, they normally use a carbon brush. Okay, so this is a carbon brush. This is a good quality carbon brush. So this is what you call carbon brush. Okay, it's carbon. It's just like your pencil. Okay, this pencil, right? The pencil lead. Okay, this one is pretty much the same thing, but the difference is this one they put a lot of extra things inside. Okay, this is a branded, this very high quality one. This thing is the cheap one lah. But the thing is that when you go to the market and buy, they can use this one. They can use this one, and then your motor lasts only 2 weeks. Okay, so the companies like Hitachi have been doing this kind of thing for a long time. They know exactly what to put inside there. But you as a customer, like me, also I got PSG, also no use. I go to the shop, how I know what's inside there. So the only way to make sure I get the right this one, I see brand DeWalt. Okay, I know DeWalt's the top brand, the main tool in the world, number one, DeWalt. Okay, and there's a DeWalt shop in Kuching, so I can buy this high quality one. See, I've experienced that because I work in a factory. So I went to buy this one because one of my motor in the factory spoiled. So I went to buy this. I asked the original supplier from USA, hey, how much this thing? Don't rush. 80 ringgit, I think. One of this. I mean, one set, normally two. There's two inside here, I think. Yeah. There's two. There's always one set. Okay, two. Okay. Because you need two to hold the rotating shaft. Okay. So I asked the US company that made the motor 80 ringgit. So I go and ask the local store near the factory, hey, how much is one? This one 1 ringgit 50 saja. Wow, I thought I'm a very good engineer. I saved the company a lot of money from 80 ringgit to 1 ringgit 50 cents. Feel good, like a good engineer. I go and put this inside the factory. You know what happened? 2 weeks later, the motor stopped. When the motor stopped, you know what happened in factory? It's very dangerous for motor to stop. The thing that you're making is all wrong already because one motor is not turning. The production is all wrong. I made the factory lose $800 US. Okay, so I thought I was a good engineer, but I was a bad engineer. Okay, to buy the wrong part. Okay, so there's no way you can tell what's inside here. There's no research lab in Sarawak that can tell what's inside here. Okay, the only way to make sure you jangan kena tipu, you get from original people like this. Okay, or Hitachi and DeWalt. So far, in my knowledge, Hitachi and DeWalt in this Sarawak market are the good ones. But you must somehow don't get someone to go and chop Hitachi and there. It happened to me also. See, I was getting. Later, I went back to the US factory because of that incident in the factory. I went back to the US factory and buy from them. But problem with buying from US that's why your factory, a high-tech factory, is not doing too well in Sarawak because we got a lot of issues with import-export. You know, I custom check here, custom check there. By the time 2 months to reach Kuching from US, how to do business like this? I think Cebu easier they do underground, so very fast. Next day can reach Cebu. But in Kuching, everything custom. Sometimes the ship have to go to KL before come here. Ayo, what nonsense! You have to go to KL before can come to Kuching. I know in Cebu they bypass all this, so it's very much faster in Cebu somehow. But this is nonsense and it hampered our business a lot. Okay, not only coming in 2 months, going out also. Going out, we need after Kuching, we make hard disk, computer hard disk in Kuching. I work for Western Digital after Cisco. So we send the product to next process is Penang. No, I have to stop in KL. Why? Government regulation like that. Yeah. So take 2 weeks to reach Penang. High tech, you cannot have 2 weeks delay or that's why this kind of issues is a big problem. So our big boss go and talk to the YB all, but still no use. So it's a big issue lah. Okay. You see, Singapore is so much more expensive than here because our labor, our cost of our salary not so high, right? In Singapore. But they can compete with us. How can factory can still survive in Singapore? They pay their workers so high. Why? Their custom all very easy. My friend told me sometimes Kuching has said take 2 months to receive a part from US. Okay. Singapore, next flight come in, arrive Singapore, done. You see, the cost of business is not just your salary of a worker, you know. All this kind of thing is money also. You wait so long, your production down. You see? If you can solve that one, you can pay your workers high, still can survive. You see? So you must solve all this kind of issue. It's not just worker salary. There are all other costs also involved. Okay. So we didn't solve the custom issues, or I don't know, but I think now they're solving it. Now the Sarawak government is, I see, from what I see, very the action. Okay. Last time they kind of bullied. Okay. 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 So what is happening? Why the wave is like this? So they will use electromagnet here. Okay. When this one pass this one, it's exactly the same as like this. Okay. When you pass that one, you got current this way. Okay. You pass, you current this way. Okay. So if you want more current, you see you got a magnet and pass, right? You get current, right? You want more current, what do you do? Okay lah, long magnet as long as that one. So become one wire, one magnet. More current, right? Because you got, okay? So you got more current, right? Otherwise, you can, this long wire, you turn into a coil. It's still long, right? It's still long, but in a short area only. You pass a magnet over and produce a lot of current. So that's how you get a lot of current, by using a coil. Okay, you get it. If you have a long wire, you have a long magnet, you get a lot of current. Or this wire you make into a coil. So a long wire become in a short space, and magnet pass by it, you get a lot of current. Okay, so that's how you get more current in a generator. Okay, so when this one pass this, you get a lot of current. Okay, but this one, when it passes one, you get a high. So that's why the wave is high. Okay, and this one is anti-clockwise, right? So when this one passes this one, it'll be a low. So you get a high and then you get a low. Okay, when this magnet is here like this, is the point, like, is it high passing the magnet passing the coil? This is when the magnet is like this. The coil is on top and down. Okay, so you get a high when this one is passing the coil, you get a high, and when it is at the 0 point, the magnet is like this. The coil here and the coil here. Okay, and when it passes this way, you get the low. Okay, that's why the wave is like that. Okay, but what is actually happening? They draw the diagram like that. This one is time. The x-axis is time. Okay, what is actually happening is the current, when it goes past the top one, is going to Sarawak. Okay, because it's clockwise. These are anti-clockwise. So when it passes, the bottom one is coming back from Sarawak. Going to Sarawak, coming back from Sarawak. This one coming back from Sarawak. So it, actually in a wire, okay, so I'll show you this wire. So in a wire, if the power is from Bakun, the current going, that will make the next electron here also all the way to Cebu. Okay, from Bakun is going like that, all the way to Cebu also going like that. Okay, until Cebu. Okay, so that is the meaning of AC. Okay. Okay. So AC is alternating current, DC is direct current. Alternating because it alternates, you see. Go to Sarawak, come down here, come back from Sarawak. This one pass this one, go to Sarawak. This one pass this one, come back from Sarawak. So goes, come back. Okay, that is alternating current. Direct current is exactly like a pipe. Say I'm a Sesco generator. My body is a Sesco generator. And I got buildings, house, and I come around like this, right? Okay. So if I'm Sesco generator, it's going like that, come back. Like I'm like a pump, water pump. Okay. But in AC, alternating current is going like that. Okay. Back and forth. Okay. In sana, that's the meaning of difference between AC and DC. So I'm a Sesco generator. If DC is going like that, kind of like pump, like a pump. AC is like that. Okay. 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 So I hope you understand the meaning of AC. Yeah. Okay. Why they want to use this AC? That was the question. Because DC looks simple, right? You see, the founders of electrical are these two guys. I mean, there are a lot of people earlier than them, but the main guys really doing the thing is this. Okay, these two guys, Edison and Tesla. Okay, Edison was a great inventor. He was a human, hardworking human. Okay, Tesla, I'm not sure what he is, but he is beyond human. Okay, I can tell you that he's beyond human. You can read all his works. I doubt. If at all he's human, he's a different level of human life. Okay, way beyond nowadays scientists. Okay, how I know that? Okay, you see the Samsung phone or Apple phone, right? Okay, I'm sorry. You can hear me now, right?
Yes.
Okay, sorry, I clicked the wrong button. So, okay. 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 How I know Tesla? I mean, some people actually don't like Tesla. Big business don't like Tesla because it's too smart. Okay. So there, if you go to internet, there are a lot of websites about Tesla. Okay. I'll show you Tesla again. It is Tesla. Okay. And this Edison. Okay. So what happened is Tesla is from Croatia. Okay. Somewhere Eastern Europe. Okay. And then he was super smart guy, never got a B in his life, only A. And then he went to France to work for Edison because Edison was already a businessman. Okay. And then he had expanded business all the way to France. Okay. So the French boss was impressed with Tesla, and then he wrote a letter to the big boss in New York. Hey, I got a very smart worker here. You want to bring him to your HQ? I said, okay, send him over. Okay. So the young Tesla started working for Edison. How Edison made his big money was he started electrical system. The first electric system, they call it grid, was started by Edison. Edison's education only 3 months. 3 months kindergarten. Okay. So you cannot say he's not educated because he go to library and read all the books. The whole library he read. Okay, so you can say he's self-educated. Tesla, on the other hand, went to normal school all the way to university, first year only. First year electrical engineering, and then he didn't continue because he had argument with the lecturer. He was right, lecturer was wrong, but because of argument, he had to quit. Okay, so that's what happened to Tesla, and then he worked for Edison's factory in France, and then later moved to the HQ. But later quarreled with Edison, and then he started his own business. Okay, so he became a very rich man also. Okay, but not as rich as this guy. This guy is super rich. Okay, so what did Edison do? New York, it was very cold, right? So he told that they all have fireplace. Okay, they all have fireplace in New York, right? Let me continue the story because we need to take a break. We cannot have 3 hours course, right? So we take a 10 minutes break and we continue again. Okay, then I tell you the story. Okay, so like I said, I tell you the story of Edison and Tesla, so that completes the story of electrical introduction. Because if you don't know history, it's very hard to understand what's going on. Okay. So Kelvin had to leave to the clinic. Okay. All right. Okay, so what happened to Edison and Tesla? You see, Edison like DC. So DC very simple to understand, right? You just like a farm, going to all the things and coming back. Okay, so it's very easy to understand DC. Okay, but AC is going back and forth. Actually, Edison's generator produced AC. Okay, so he used carbon brush system to make it like that. So as long as like that, it looks like wavy, right? But it's still DC because it's above the zero. Anything above the zero is DC. Okay, it can be even like that, but it's above the zero is still DC. Okay, direct current. Okay, so it's not a clean DC, but it's still DC. The best DC is like that, straight. Straight is the best DC. The only place where you can get the straight DC is battery. Okay, anything else is a bit wavy. Okay, the handphone charger is pretty good. Okay, but it's not a perfect DC. The perfect DC is the battery. Okay, but this is, as you get later and later, handphone is getting pretty straight, but not straight enough. Okay, the only thing really straight enough is the battery. Okay, so remember that the difference between AC and DC, because you definitely will be required to know that in your kind of work. Okay, so DC is straight. The handphone charger gives you almost straight, but not straight enough. Okay, the later handphone is more straight than the old handphone. So I think it's not a wise idea to, if your handphone charger spoil, you're going to buy a whole model. It's not a good idea, especially your handphone expensive. My handphone cheap, okay lah. Okay, this one I bought because mine spoiled. My Asus charger spoiled, so I bought a Samsung one. Okay lah. Okay, Samsung is quite a high-end company. Okay, so the later handphone one is a little bit wavy, but it's pretty much straight. Okay, I'll explain to you that one later topic, how they made it straight. Okay, so remember AC is like that. Just get that fundamental, because this course is called fundamental, right? AC is like that, DC is like that. But if this is zero, like that, it's still DC. Okay, even like that, it's still DC, as long as don't go below zero. AC means go below zero and come back. Go below zero, come back, then only AC. Okay, so anything like that, even like that, okay, like that, it's still DC. Okay, it's a dirty DC. They call it dirty DC, not clean DC. Okay, the cleanest DC is from battery. Okay, so you must understand the difference between AC and DC. Why? Because when I talk to you about the Edison Tesla, you have to know what's meaning of AC DC. Okay, so what they did is so Edison started the first system, and I told you he used an AC machine because the only way you can generate power is using an AC machine. Okay, AC generator. But he converted to DC, but not a perfect DC. His DC is like that. This is zero, it's like that. Okay, it's a bumpy DC. Okay, but it still works like the straight line. So straight line easy to understand now. That's why the whole electronic system is using DC, because when you use AC, a lot of complication arises. Okay, that's why Edison don't want the AC, even though his original source was producing AC, and he definitely know the AC can power different things, but he don't want to use AC because it's very complicated. It's really complicated. Okay. Later they had an argument a long time after the AC-DC war between Edison and Tesla. They fight each other. They were called in by the richest man in America, J.P. Morgan, and then he invited these two, Edison and Tesla. They were enemies already. So he invited them, and then each give the point of view of AC and DC. So Edison's argument is AC is very complicated. It really is complicated, but it has one big advantage. Okay, I'll show you the advantage later. Okay, so Edison built the first grid. Grid means one generator you supply to some area. Okay, his area was about 1 kilometer because DC cannot go more than 1 kilometer. Okay, and DC can only go about 1 kilometer. After that, the voltage start dropping and cannot use. Okay, so he started the first grid, but what did he use it for? To boil water. That's the first use for electricity. Okay, why? Because New York is cold, right? So cold, you need a fireplace. Okay, so if a fireplace in a house all over Europe is okay, because if it is, if it catch fire, you can run out of the house, right? Easy. But New York was starting to go up high. Okay, so if one house burn, a lot of people die. So he went to the mayor of New York. Okay, New York mayor said, if you can solve this problem, I can give you all the business. Okay, so that's Edison. He go and get all the best skilled people, not necessarily smart, not educated, smart. Tukang paling bagus, tukang besi, tukang cement, everything, the best one he go and get all over America. He asked them to join him. Okay, let's put all our brains together and figure this problem out. New York got a problem of burning fireplace. How to solve this problem? So they come up with an idea. We use electricity to boil water at the bottom of the building in a big container. And then going to each house, we put a piping that goes in the spiral. Okay? Spiral and come up. You know why they use a spiral? You see, if the pipe just go to your house and just one loop like that, there's only that surface area to release heat to your room. Not enough, right? So if they put a spiral like this, there's more surface area to release heat to your room. That's the purpose of the spiral. Okay, so you go like that. Okay, so that solved the fireplace problem. So water is boiled, it goes to every room, it goes in a spiral and come back to every room in the whole big building. You got this water going up. Okay. When I was in US, that thing is still there because my building is very old. Where I rented, it's a very old building. That thing is still there, but it's not being used. But the boiler at the bottom of the building is still working. So where I studied in US is one of the coldest places in US. Super cold. And we cannot afford the heat because we are poor students, all from Malaysia. So we use jacket, thick jacket. It was so damn cold. So but we take bath very long time. Why? Because water is free. Hot water is free. Okay. So that's the only place we can get heat. Okay. Because we cannot afford the normal heater. Electric bill too high. We cannot afford it. Okay. So once a day we take a long bath, sometimes 40 minutes bath, and get some heat. Okay. Because where I studied is a minus 40 degrees centigrade during the coldest part of winter. Okay, minus 40. Remember, just below zero is already freezing. It was minus 40. Okay. During Christmas time, that's the coldest part of the year. Okay. So that business became very good, and all the cities decided to use the Edison system. All over US, they throw away the fireplace. They use this water system. Okay, and then it moved to Europe. Those days, America was a, cowboy people. Not so smart people. That's what the Europeans think of America, lah. The useless people, lah. But so normally the technology from Europe go to America. This is the first time from America go to Europe. Okay, Edison is the first time from America to go to Europe because Edison got the system to warm your house without fireplace. Fireplace, you got smoke, and then you got fire danger. Yeah, this one no problem at all. No fire anyway. Yeah, just heater to boil your water. So very good system. So all over the world, they start using this system, and then he became very rich lah. In those days, one of the richest men around. Of course, there are certain. If you know the history of finance, that's why I went to economics for my masters, because I learned all about engineering. I think I'm quite good in engineering, but this finance world looks very strange to me. Something is wrong. So I did my masters in economics and my PhD back to engineering. Okay. So I want to understand what's going on. I found out that a lot of nefarious things going on in the financial world. There are certain bankers who control the world. You can be rich like Edison, but you cannot be super rich. Super rich are chosen people, chosen by certain bankers in Switzerland. Switzerland control the world's money. Even Malaysia's money, they all control by Switzerland. Okay, and those bankers will choose who their people are. Okay, so the super rich must be the banker's choice. The engineers who make money can only be certain level only. The super rich are not in the list of richest men. You see the list of richest men, you see Bill Gates, all that. They are not the richest men. Richest men in terms of trillions of dollars. Bill Gates only billions of dollars only, maybe 100 billion. Jeff Bezos, 100 billion like that. The super rich are trillions of dollars. Okay, they don't want their list anyway. They control, but they in the background. So that's how I know about finance. Okay. So you cannot kacau those super rich people. You say bad thing about super rich people, they take revenge on you. Okay, so I think Mahathir did that. He took some action on the super rich people, and then I think they caused them some trouble. Okay. So so JP Morgan was one of those super rich people, banker's choice. Okay, Edison was rich, but JP Morgan was a banker's choice from Switzerland. Okay, so he called a meeting, and then they discussed, and finally decided to use AC. Okay, so what is the advantage of AC? You see, AC or DC can power your bulb. Oh yeah, by the way, Edison made the bulb later. The bulb metal, he made it later after the water system. Because after he already solved the water fireplace problem, there's another problem. Everyone using the kerosene lamp. Okay, kerosene lamp also can burn the house. So the mayor also asked him, "Hey, can you solve this problem also?" So he come up. Oh, he worked very hard. I tell you, he is a real human. Human must work like him if you want to succeed. I don't think you cannot just think of money. You have to think other things also. Okay. But his aim was also good because he was solving the world's problem. It's not just money. He was solving a serious problem for the world. Because everyone using kerosene lamp and kerosene lamp can burn. Okay. So you must do something to solve the world's problem. You're not just money-minded. Actually, if you're just money-minded, you know where you end up. Gangster, of course, gangster make the most money. Obviously, if your aim is just money, your God is money, you end up as gangster because gangster make the most money. Because always the highest risk is always the most money. Okay, but your aim should not be that. Because you can see the life of gangster and they're getting killed here and there. I heard one of them, a Bintulu gangster or something like that. They tortured his brother. The rival gang tortured his brother, killed his father. You live a life like that, no security. Okay, but then you get killed here and there. But the money is good, but you have to take all that problem. I mean. That's not the aim of human life, come on. It's you need to do something else, okay? Especially helping other humans to live properly. So Edison was helping because he solved the people burning problem with fireplace, and then next he solved the kerosene lamp problem. Okay, so he invented the menthol, so the bulb. So he tried a lot of things. I heard he tried about 1,000 different materials. And then he finally solve how to make a bulb. Okay. Wait, let me get my bulb. Okay, so Edison made this. Okay, very hard to find, but they say every house must have one of this. You know why? All the other modern bulbs, like LED bulbs, all you got a surge in voltage, they'll get destroyed. But this one, I already tried in the UCDS lab. You put one voltage, I put 415, that means double the normal voltage going to this. It's still very bright, but it didn't die. Okay, so if you all your part in your house, you change your LED, at least this one you must keep one. Okay, so this is the Edison's second invention. So now the material in there is tungsten. Okay, the filament there is tungsten. But actually, before that, he used a Japanese bamboo. Okay, he used a Japanese bamboo. And then finally, they turned to tungsten, because tungsten is the element on Earth with the highest boiling point. So they use tungsten. Okay. Okay, so now he solved two huge human problems. I believe I believe God rewards you if you can help other people also. Okay, that's why he became rich, because he helped solve two human problems: fire-based problem and the kerosene lamp problem. Okay, so he became rich, okay. But he still has to be under the control of the world bankers. Okay, but he was using DC the whole time, and then Tesla came. Said, hey, our generator is producing AC. You see generator like that, it definitely go that and come back. That is AC already. So Tesla said, we use AC now. And then of course Edison said, you get out of here. I mean, nonsense, you're talking nonsense. So he quit. And then he started his own business. And then he did very well because he is a super smart guy. Okay. Most of the electrical system design in the world right now is from Tesla. Edison did a lot, but the AC system, which is what we're using now, is mostly from Tesla. Okay, so okay, see, the reason why we need to use AC is because of transformer. This is why I told you how transformer works, right? Okay, so if you look at Sarawak, okay, this is Sarawak, eh? Okay, our main power is coming from Bakun. Okay, coming out of Bakun is 11 kV. 11 kV means 11,000 volts. Okay, it's the same incoming to your housing estate substation. You know, all housing estate in Cebu or all over Sarawak, you have a substation where the power is coming in. Okay, incoming to that substation is 11 kV. Okay, it's definitely dangerous, but it is it's still okay for humans to be around it. Okay, that's why Bakun is running at 11,000 volts. Okay, K means kilo, okay, kilovolts. Okay, 11 kV. Okay, so this is a transformer, and it steps it up to 275 kV. Okay, sorry, 275 kV. Why they do that? Because you see the water falling down from Bakun is power, right? The power of water is P. V has two components, V and I. Okay? When you put the V very high, automatically the I will go down because this is the power of the water. But when you change to electrical, it has two components, V and I. Okay? This is a formula. This is other than V equal IR, this is another formula you must know. V equal VI. Okay? V equal IR, V equal VI. Okay? So the power of water has two components. The force of water coming down. When you convert to electrical, it has two components, V and I. So when you push the V very high, the I will come down. How you push the V very high? Transformer. How you do that? Sorry. You see, transformer are two coils, right? Two coils. If you put here little bit coil, say two coil a bit, okay, and here a lot, you step up. Okay, exactly according to number of coils. If here two coil, here got say 4 coil. So the voltage you put here, come out here will be double voltage. Okay. So the amount the voltage goes up is exactly proportional to the number of coils. Okay. So that's how they can step up the voltage using a transformer. Okay. How does it work? It works like just like I told you, due to varying fuel density. Just like from here can go to here, you don't know connection. Okay. Okay. So that's right. Okay. Okay. So the V goes up very high, I comes down. Why you want the I to come down? The I is the thing that make the wire hot. Okay? The I is the thing that make the wire hot. V is a force to push electron, but the I is like can say the number of electrons inside there. Okay? So the formula to make the wire hot is E equal to I square. Okay? But you put I that is very low inside this formula, so the P become the P loss. The loss, that means the thing that make the wire hot. The wire hot is lost, right? The thing that make the wire hot becomes low. Okay? So that is the reason why you use a transformer. And it's a transformer that killed Edison system. Because I told you Edison system is only 1 kilometer in New York. 1 kilometer, one generator. Another kilometer, another generator. Okay? So every kilometer, he need one generator. Which is very good because he can sell a lot of things, make more money, right? He's in business, so he liked this thing. But Tesla is different. I told you Edison helped people, right? Tesla is all the way help. He don't care money also. Okay, he not need money also. Now, man, as long as I can help people. So this system, you look at the system. Just one Bakun can power the whole Sarawak. Pretty much lah. Most of all the time Bakun. Okay, above Bakun is one dam called Murum. Okay, between Bakun and Murum is powering most of Sarawak. Yeah, there are a few other generators lah. But majority about Murum and Bakun. Okay, so you see, you cannot sell many things. You have one Bakun powering the whole Sarawak, so you don't sell like one every kilometer, one generator. So you don't have much sales. So business is not so high. Okay, but Tesla don't care. He don't care about money as long as people get a good thing. So I believe, I mean, you help people, you get rewarded now. Yeah. It's you do good thing, you good thing come to you also. So Edison did good thing, he got rich. Tesla also did good thing, and he became rich. Okay. So this is the only reason why Edison's DC system got killed. Okay, just because of transformer. Okay, only transformer killed the DC system. Okay, because you can step up. When you step up, you have very low loss in the lines. You see the wire size, this is very critical, especially for you. The wire size. You see, in electrical, we got PVIR. Okay. Okay. You see, in electrical, you got PVIR. There are 4 different things: power, voltage, current, and resistance. Only I determine the wire size. Remember that, very, very critical for the rest of your life in design. Okay, the wire size only depend on I. Okay, so what they do is they put the voltage very high, so the current become very low. So the main line connecting the whole Sarawak is not so big. The wire is only about this small only. Okay, only that small. Okay, so you don't need big wires. But in factories, some of the factories you can see wires very big. Okay, because they don't have the high V. They have low V, so the wire must be big. Okay, so when I and V, when one goes out, other than they come down. Okay. Okay. So this is very critical, especially when you do design. Make sure your wire size is right. If not, you have a fire. You can use extra wire size, no problem. Don't use less. Use extra, you never get a fire. But the problem is the price. Okay. When you use extra wire, the price is very high. Okay. Okay. Bigger wire size, no problem. Anytime you can use bigger. But when you use small, is a danger. Okay. Too small, you get a fire. Okay. I've seen fire in my factory. You got people use too small wire. It's actually burning. Okay. Okay. So this is the story behind Edison and Tesla. Edison came out with a system, and then he helped people solve 2 major issues: fireplace burning and kerosene lamp burning. Okay. Tesla came around, and then he said, no, we send AC out. Why we can use transformer? This transformer, the I becomes low, so we can send far away. The whole Sarawak can power with just one generator. Cannot make much business because only one generator making all the power, so cannot make much business. Selling all the generators like Edison was doing. Okay. Okay. But he fought against Tesla. He tried to kill the DC system, which is a bad thing of him. Okay. I mean, he knows it is better, and he still fight it with a lot of vicious attack. Like you kill an elephant with AC. AC is Tesla's one, right? Kill an elephant with AC just to prove that AC is dangerous. And he killed a human. He made an electric chair. Now you got electric chair to kill people, criminals, right? It's invented by Edison. Using AC to prove that AC can kill people. Actually, use DC also can kill. In fact, DC can kill even faster. Okay. So these are all the tricks that he did, and I think people dislike him. Like my son, he totally disliked Edison. Okay. I mean, a lot of people, I'm sure, dislike Edison because of those things he did. Killing people, killing dogs. All the dogs in the New York neighborhood died because Edison killed them with electricity. Okay, so he did good thing, but he did a bad thing. So plus minus, in the end, people don't like him lah. Okay, but Tesla so far he didn't do any bad thing, but he was so genius. The big people don't like him. You know why? See, he already killed the electric industry with his idea. I mean, kill means they cannot make as much money as last time already. They cannot sell generator every kilometer. Okay. So he already killed the electric industry, but that's the first time, so they let him go through. Okay. Then he's going to kill other industry also. He said farmer got a lot of problem. Farmer need a fertilizer, right? Fertilizer is ammonia. Ammonia is NH3. NH3 is ammonia. Okay. NH3 is ammonia. But the plant only need this one. It doesn't need this one. But he said the this A got 78% of nitrogen. This is nitrogen. The A is only 8% nitrogen. Why don't I get that from the A and put it inside the ground? So he made a machine with free energy. He know how to make free energy. You see, you look at it's gravity, right? Gravity is power, right? How come nobody use that power? If you make free energy, you will realize something. People come after you and try to kill you. Okay? Because it will affect the oil and gas industry. They are very angry if you can make something cheaper than them. You see, this one, that's power. This thing falling down, a lot of power. What can you utilize that power? Okay, so he made free energy. He know how to tap this power. I mean, various other kind of power also lah. Okay, all over the universe is power. Okay, so why can't you just take that power from the universe, which is all around us? Okay, so Tesla managed to do it, free energy. Okay, so he made a free energy machine. You take the hole, charcoal, and pour inside the machine. The machine will put the nitrogen inside the soil. So come out of the soil full of nitrogen filled soil, which is fertilizer. Okay. Free machine. Farmer all they do take a hole, put inside there, and come out fertilizer. Okay. So free fertilizer. That killed the whole ammonia business, the fertilizer business. Okay. Fertilizer business don't like him at all. Okay. You see, they already let go him for the electric business. Electric people told the fertilizer people, you see what this guy is doing. Last time he killed our industry. Now he's going to kill your industry also. So they're all going to hire all big gangster, try to kill Tesla. Okay. So next thing he do, wireless power. I told you Samsung, Samsung phone, you put like that, you can charge, right? Wireless charging, right? You know what Tesla did? He made a tower. My pen died. Okay. Okay. So Tesla made a tower like this. Free energy. He got free energy. His plan is send it out there to the outside of the world. There is a layer of gas called ions. They call it ionosphere. Okay. So it will travel along because ions are conductors. Okay. Anything ion. What's mean ion? You see. Sorry. Okay. You see, this is atom. 2 proton, 2 electron, atom. 2 boy, 2 girl, satisfied. Okay. But here, you got 2 proton and only 1 electron. Kelahi nanti. Okay. Okay. So it's not satisfying. So these things are very reactive. It's looking for another electron. So these are called ions. Okay, this atom. Okay. So there is a layer outside the world which is ionosphere. Okay. Anything that's ion, say this one, is plastic. But when plastic becomes ion, it's a conductor. Okay. You got another plastic here, or you got plastic, metal. You got metal, you can change it for ion, you'll be conductor. Oh, metal is already a conductor, but you'll be a better conductor if it is ion. Okay? So anything that's ion, plastic or wood or anything, if you change it to ion, it'll be a conductor. Okay? So so he sent out electricity to the outside, he traveled around the world, and then a house in Malaysia, this house in Malaysia, can put a tower there, a small tower, only 1 feet tall. It can take the energy, free energy. A ship in the middle of the ocean, no need to carry petrol. You can take the energy. In Japan, you got a ship. You can take the energy from the atmosphere, and the ship can run free. Nobody needs petrol. So what's going to happen? Petrol industry bankrupt. Okay. So in one go, he can kill electric industry already mostly bankrupt because of him. So fertilizer industry bankrupt, and then he's going to kill the with this system. He's going to kill the petrol industry, and he also killed the cable industry. He said, "No need wire. I use wireless." So imagine how smart is Tesla? Samsung or Apple, you have to put like that to charge wireless charging, right? He not only like that, in space. So he is far more advanced than the latest technology right now. Latest is like Apple, Samsung are the high-end handphone, right? The most expensive handphone, Apple and Samsung, right? They can only charge like this. That's the top scientist in the world right now, top scientist. Tesla, 120 years ago, he can put this one in the sky. So you can see how far ahead is Tesla compared to even today's scientists. Okay, so with this system, he can destroy he already destroyed electric business, and he can destroy the petrol business, he can destroy the cable business, and the fertilizer business. 4 big business he can destroy. Okay, so a lot of rich people, they don't like him at all. You know what will happen? Okay, you drive from Cebu to Kuching. No need to use petrol. Your car is no more combustion engine. Your car is an electric motor. Okay, just like your drill. Okay, that drill, the motor will never fail. Other things fail inside your drill. Motor normally doesn't fail. Very hard for motor to fail. Okay, so that car mechanic also no job. Electric car, because it's too good. Normally, electric car is not a motor that fails. Sometimes a motor fail, but very rare. Okay, if you look at factory motors, hardly ever fail. Okay, so you got you can drive from Kuching, from Cebu to Kuching. Your car no need petrol. Uh, 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 your car will never fail unless it hit an accident or something lah. Okay, so mechanic also no job. And then when you stop by somewhere in between Betong, or not Betong lah, I forgot the name of the place. There's a rest stop somewhere in between. You eat. The food also very cheap. Why? Because fertilizer free. So it's almost like a perfect world for the poor people. Okay. So, but the rich people can make money. Rich people make money with petrol industry. They make money with fertilizer industry. They make money with, cable industry. Okay. All rich people make money with all these big industries. Now, rich people cannot be rich. So everyone become about equal. This is not good for rich people. Rich people said this is disaster. We all become equal. They don't like the one. They want to be the boss. Other people slave. They like that. They don't like everyone equal. Okay. Some of the rich people are very arrogant. I know some of them. I didn't meet them, but one of my friends told me the three richest people in Kuching. They go to a pub. Ask the waiter to crawl on the floor. Why? I'm rich, I can do that. Wow, like that. Wow, it's really bad. Okay. The waitress ask the waitress to crawl on the floor just because they're rich. Okay. So the rich like to keep their power of arrogance. Okay. So they don't like this Tesla's ideas, which make everyone about equal. Okay. So they give me a lot of trouble. So if you go to internet and type Tesla, you see a lot of good thing and a lot of bad thing also. The bad thing are written mostly by the rich people because they don't like him. They are destroying his business. But what I hear, there are some groups in the world who knows of course who knows about the good things of Tesla, and they're trying to bring back all these things. So the world will be like a perfect world. Okay, there'll be no rich, no poor. Just the poorest people can live quite a comfortable life. They can have a car, no need petrol. The car must never break down. Food is very cheap. Okay, but rich people cannot be rich because they don't have all the big business factories to run. Okay, they can sell kampung ami and be a bit wealthy if they work hard, but not super wealthy right now lah. Okay, they sell a lot of kampung ami, they be a bit richer. That's it lah. Okay, not like now these people in oil and gas and these big factories, they're super rich. Cannot be like that anymore. Okay, so it's almost like a perfect world, but the rich people didn't like it. So worldwide rich people go and hantam of Tesla's invention, and they write a lot of bad things also. If you look at internet, sometimes they say it's bad nonsense. It's mostly sponsored by the rich people, but there are some group going to bring all this up. I'm pretty confident they'll succeed. Okay, so we'll have a good future, I think, in the near future. Okay, everything will be electric. There'll be no more combustion cars, and then the electric will be free. Okay, so the world will go back to zero global warming. Everything will be very nice, but of course you cannot be lazy lah. You must exercise and do your spiritual development and all that lah. Okay, keep everything too nice and then you just relax is also a bad thing. Okay, you must do your spiritual. If we are here for that, I believe to help other people and all that. No, not just enjoy drinking, smoking, whatever. Okay. So I'm sure the electric world will change it very soon. Next few years, probably even next year. Okay. Yeah, another thing he invented, Tesla. He found frequency because he's expert in frequencies. Frequencies, how they move. So he can modify frequencies until it repair your body, because our whole body are just vibrations. Okay, our whole body is vibrations. So he found that say this part pain, he can get a certain frequency put in that place, repair that part. No need to cut anything. Just put the frequency. Okay, sure. Okay, he did that machine. It's called MedBed, MEDBD. You can type internet, you can find. It's already out there. Okay, MEDBD bed. So it can cure anyone of anything. Okay, so it's almost a perfect world with Tesla's world, the world that Tesla wanted to bring about. But rich people don't like. The whole medical industry will die. All doctors no job. Okay, so. Mostly everyone will be about equal. There's no rich, no poor, everyone will be equal. Which is what the communist people wanted to do, but they use a different route. Tesla's ideas using technology to do it. Okay. Okay. So, I mean, you can't really force people to be exactly equal, but I mean, not too far different until one guy abused the other. Just like I told you the story of the three richest people in Kuching abusing waitress and all that. That's because they become way too rich until they feel they can do anything they want. Okay. So what Tesla did, Tesla's idea was to solve human problems so that human can live very peacefully. And he did this 120 years ago. Till now, we don't have all his inventions. But there are some people who kept it secret. Okay? And most of the big government have it secret. Okay? They know it and they keep it secret, and they're going to release it soon. That's what I heard. Okay? Okay. Okay. So I hope you understand all this. How the Edison system and the Tesla system, the AC and DC. Okay, DC is simple to understand. AC has a lot of problems, but you can work out the problems is much more advantageous. Okay, because it's more simple. Okay, more simple in the sense that you see, Edison system, you turn around in a generator and you produce AC. And then you change it to DC and then send it out. And you cannot send too far. Tesla system, simple, you got a motor. The motor and the generator is wired exactly the same. So if Bakun turn like this, the motor in Cebu will be like that also. Turn like that, it follow exactly synchronized. All the motor in Cebu will follow Bakun. So it's direct connection. Okay. So in that way, it's simple. But there are a lot of other problems, mainly because the voltage. I told you V and I are two different factors of electrical, right? The V and I wave is like that, right? But they can move apart. They move apart. Okay. This is the biggest problem in electrical with AC. Only AC this happens. Okay. So they move apart. So that causes problems. And so Cisco had to solve all these problems. Okay? So how they do it? They play around with these two things. Because most of the work for humanity is done by inductor. Inductor is a coil. Okay, there are three words for coils. Okay. A coil is also an inductor. Also, they also call it a reactor. Okay. So most of the work for humanity is using coil. So coil is inductor. So inductive reactance and capacitive reactance, how they solve the problem. Why? Because if when the AC is going inside the inductor, the current will go back, will go behind the voltage. The current will go behind the voltage. Okay? Go behind the voltage. The capacitor will make the current go ahead of the voltage. So what they do is they play around with these two such that they go exactly the same. In inductor, a bit too much. Put capacitor in. Put capacitor in. Okay. Same. So they play between inductor and capacitor to get the V and I to go the same. Understand? So that is one of the biggest problem in AC, which is what Edison was saying is a complicated thing. Yeah. Edison says too complicated is this thing. This is the complicated we're talking about. Okay? Because it moves. DC it goes the same. But in AC it moves. Okay. So that's why in all factories or big hotels or big office building, you need capacitors. I don't have capacitor here. You need a capacitor to back up the building because building mostly use coil. Your aircon is a coil. Your fan is a coil. Okay, everything that you human use electricity mostly are coils. Okay, so human use coils to get electricity to help them. Okay, but the coil will make this thing happen. The V and I move. So they need capacitor to put it back. Okay, Cisco don't want like this. They want like that. They want the same. Okay, so big factories, big building, hotels, they must have capacitors. If they don't put capacitor, Cisco will find them a lot. But Cisco got their own backup also. In the substation, the big substations, they have their own capacitor. So if the factory or building, say tall building in Cebu town, don't use capacitor, that will make the town of Cebu like that. Because the building is so big. For example, the tall building in the center of town was at RH. I forgot. There are some I forgot the name of it. Something, eh? I forgot. Never mind. There's the tallest building in Cebu. For example, the capacitor not working in that building. And that building is so tall, right? So it affects the whole Cebu because the building is so tall. So the whole Cebu will be like that. But Cisco won't let that happen. Why? Because in Cisco substation, they have their own capacitor also. If people don't do what they're supposed to do, Cisco got their own backup system. Okay, to make sure Cebu is still like that. Okay, so if you don't take care of this problem in your own, like the tall building in center of town, they are like that. The fine is very high. Cisco charge a lot of money. Why they charge a lot of money? Because they got to use their own capacitor. So their own capacitor lifespan reduce. Okay, so they charge you a lot of money. A lot of money, I tell you. I was repairing one school, SMK. I changed all the capacitors. That school bill increased by 7,000 every month now. The school, SMK, increased bill by 7,000 every month because they didn't take care of this one. Okay, the school capacitor bank not working properly. 7,000 extra per month. Imagine a big factory. School not so much power now. Imagine a big factory, how much the charge is. Okay, it is terribly expensive. Okay, so that's basic. Today I'm giving you the basic fundamental of what's going on in electricity, and then the rest of the class I'll teach you more things lah. Okay, so today's things are very important. They definitely come on exam one. Okay, these are all the basic fundamental things. Okay, maybe I'll ask you about Tesla, Edison, Could I do a story of it? Okay. They are the ones who introduced the thing. There are a lot of people before them. And a famous one is Faraday, one of the most famous one. Okay, he's called the father of electricity. Faraday. Okay, let me show you Faraday. Where's Faraday? Oh yeah, here. This Faraday. So he is considered the father of electricity because he invented three things: electric motor, electric generator, and transformer. The three most important things in electricity are these three things: electric motor, electric generator, and transformer. Okay, these three things are the most important thing in electrical. So all made by him. And his education what? Primary 6. Okay. So after primary 6, he worked in a factory that make books. So he read all the books in the factory. Maybe that's his part of his job also, to read the book, make sure no English mistake. Yeah, so he read all the books in the factory. So he became quite smart. Okay, I think reading is very important. I tell you. All the smart people I know so far, I see, all are big readers. Okay, so reading very important. Okay, so he read all the book in the factory. Then the chief scientist of England, oh, this guy is smart. I take him as technician in the biggest lab in England. He became technician because he know a lot of stuff. So eventually he started becoming a technician in the lab. He became better than the boss. The boss name is, nobody know the boss name. Okay, but everyone know his name. So he invented a lot of things, and everyone take him as the father of electricity. So he is father of electricity, father of chemistry also. Okay. Okay. So a lot of people, like even Tesla. Tesla came about 100 years later. Tesla's on his wall of Tesla, he put a photo of Faraday, because that's Tesla's hero also. Okay. So these are all the other people. It started with Benjamin Franklin. He flied a kite to prove that lightning was electricity. Okay. And then, he made one mistake. He said electricity flow this way, but actually it flow. The electron is the one that's flowing. So what we are doing in the world right now is all opposite. But you do calculation upside down, you still get the same answer. Okay. So remember that we are using opposite of the reality. The reality is this way, the electrons. But Benjamin Franklin said this way. But later they want to change the book. Very expensive to change all the book. Just leave it like that. So we call this current, and electron, which is the real thing that making things work, is this way. Okay. And then later you got this guy Galvani, who made the first battery. He take two different metal and put a frog leg there, it became a battery. Okay. But he actually believed the energy is from the frog leg, but actually it's not from the frog leg. Okay, it's from the different metals that cause electricity. Okay, so Volta is the one from the neighbor town. Okay, Cebu Bintulu, neighbor town. Okay, he decided that Galvani was wrong, so he invented the first real battery. Okay, so he became very rich, Galvani became poor, and whatever. Okay. So the next one was this guy Coulomb, and then Oersted and Ampere. The current unit is from this guy. The unit of current, Ampere. Yeah. And then you got Faraday, and then you got all vehicle IR is made by this guy. Yeah. And the coil becoming a magnet is mainly done by this guy. Okay. The coil becoming a magnet. Okay. Henry. Okay. So that's his first coil. Okay. And then you got this guy who made the first use of electricity in Morse code. That one is Morse code. Okay. That was the first use of electricity in a big way. Okay. Before Edison. Okay. Before Edison, they used it for telegraph using Morse code. Yeah, TDD means SOS. I'm in trouble. You should know that one. In case you're in trouble, you can knock something. TDD means SOS. Okay. And then you got Weber and Fleming. Fleming is the one who made the rule. Okay. Fleming is the one who made this rule. Okay. He's also a pretty smart guy, Fleming. Okay, it's 11 already. See you next week, Thursday. Okay, bye.
Bye.
Thank you, sir.
Okay, bye.